Of the RC circuit problems, 73 is probably the most difficult to do. So if you can understand how to do 73, you pretty much get it. Now here's one of the things. So the question says we have a circuit and the switch is open. Their capacitor is uncharged. So the voltage across the capacitor right now is 0. The switch S is closed at time equals 0. In the figure shown, when the time equals 8 seconds, the charge on the capacitor is closest to. All right. So one of the things we're looking at is this capacitor and how to get the charge on the capacitor. So the only way to get the charge on the capacitor is Q equals CV. Okay? So we have Q equals CV. So we know the capacitance, but we don't know the voltage. So now we need to find the voltage. Okay? So right when we close the switch, that current is going to go vroom, and it's going to rush on through, and you're going to have the maximum current that you're going to have. So that current is determined by our resistor right here. So we use V equals IR to find our current. And 0.2 mega ohms comes out to 200,000 ohms. And so we do V equals IR, and that's what happened here. So we did V equals IR, and no, that's not there. Where did I do that? I did do it. Here I did it. Sorry about that. V equals IR, and so we get our initial current. So this is going to be our initial current of 3.5 times 10 to the minus 4. So that's where that number came from. Okay, so we have our initial current. Our initial current is 3.5 times 10 to the minus 4 amps. Okay, so then the switch closes, the capacitor starts charging. So our capacitor here is starting to charge, and so that's decreasing the current that's going through our RC circuit. So now that we know our initial current, we're going to use that the current at time t, whatever that is equal to our initial current, e to the negative t divided by, RC. Right. So the time is the 8 seconds. RC is our resistance times our capacitance. So that's what happened here. So here, the time is 8 seconds. When we multiplied R times C, we get 18. And so now we know that there's this many amps, 2.24 times 10 to the minus 4 amps, going through our resistor. So that's where that number came from. Okay, so the voltage across the resistor and the voltage across the capacitor have to add up to our 70. So now that we know the current through our resistor, because it's gone down because time's gone past, we're going to use V equals IR again. V equals IR to death. To find the voltage across our resistor. So that's what happened here. So when we do V equals IR, we have 2.24 times 10 to the minus 4 amps, which we found here, times the 200,000 ohms, or the 0.2 mega ohms. And so now we know that we have 44.88 volts across the resistor. And so then we can find, remember I said that the voltage across the capacitor plus the voltage across the resistor had to add up to the 70 volts. So that gives us that the voltage across our capacitor is 25.11. And that's what we were trying to find this whole time. This whole time we've been trying to find the voltage across our capacitor, because then we were trying to use Q equals CV to find our charge, which is what we're looking for. And that's what happened here. So now that we know that the voltage is 25.11 and it has a capacitance of 90 times 10 to the minus 6, 90 microfarads, then we can get our charge as 0.00226 coulombs, but they want our answer in microcoulombs. So that means we're going to move our decimal point over 6 places, which gives us 2260, which rounds to 2300 when we do sig figs. And that is how you do the hardest of the RC circuits, number 73.